Hi there, this is Miss McDonald going over the weekly agenda for Algebra 2 for November 10th through the 14th. So let's look at the assignments for the week. So you're going to be working on Delta Math 4.4 Graphing Polynomial Functions Part 2. So you're going to be still looking at graphs and doing polynomial functions like you did last week. You're just going to learn some different key features and doing a little bit more advanced graphing polynomials. As a reminder, the lecture video that you watch before each practice set of problems serves as the what you're going to be taking notes on, and then the practice problems serves as a check your understanding. You'll also receive ACT Math number 6 on paper. Make sure to turn that in by Friday. The Math Plaza, continue to do your 30 minutes in the Math Plaza, and at the end of the week, you'll have a quiz over the graphing polynomial topics that you went over this week and that you practiced with. So let's look at the Delta Math briefly. Okay, so here is the Delta Math. On this, again, you'll watch the video, take notes from the video, write down some example problems, whatever you need to do, and then you'll have some check your understanding practice problems over it. So as just a quick overview, you're looking at x-intercepts here. Like this is x equals 3, so that means the factor is x minus 3, so it's going to be one of these. Notice that this x-intercept, it crosses through or goes through the x-axis, so that means it is a multiplicity of 1. It only happens once. Whereas if you notice here, this x-intercept at x equals -4, so the factor is x plus 4, notice that this looks different. It doesn't go through the point. You can think of it as like bouncing off the point, like it touches the x-axis and then goes down, like it touches or changes direction here. This bouncing or touching the x-axis is what's called a multiplicity. It means that x value happens more than once. So this x equals -4 or x plus 4 means that it happens more than once. It's squared. So you click on it. You can also use Desmos to help confirm this, and then that's how you get the graph. You'll also have some about writing polynomial functions from the graph. Again, watch the video to do the practice problems. Then there's identifying relative extrema. Extrema is another word for minimums and maximums. So relative extrema and absolute extrema is, again, another way of saying absolute or relative minimum or maximum. What's the highest value? What's the lowest value? So highest y value, lowest value. Y value is what you can think of here. Even and odd functions are going to be talking about not just the exponents, but is the function even or odd? And it shows you can do that algebraically and then also graphically. And then towards the end, you have end behavior. So end behavior is just another way of saying what's happening at the ends of the graph. How are the arrows pointing at the end of the graph? Well, instead of saying up and down, we're going to start using positive and negative infinity. And we have some statements over here. As x goes to negative infinity, that's saying as you look at the right side, what's happening on the right? Is the arrow pointing up to infinity, or is it pointing down? In this case, up. And then as x goes to negative infinity, so on the left side, what's happening? It's saying y is pointing up, so infinity. So instead of saying up and down, we're using infinity, or left and right, we're using positive and negative infinity. You can do that graphically and also algebraically. And then at the end is determining features of the polynomial. So it's going through and kind of summarizing everything from last week and this week with graphing polynomial functions. One thing that you may want to add to your notes is this. You may want to pause the video and jot this down. It's related to the degree and the leading coefficient. So if the degree is even and you have a positive leading coefficient, what that means for the end behavior is that on the right side, it's going to be pointing up, and on the left side, it's also going to be pointing up. So this is the end behavior statement. For any polynomial that has an even degree, so remember degree is largest exponent, and a positive leading coefficient. Remember that's the a value, the number in front of the entire function. So it doesn't have to necessarily look exactly like this. We don't really care what happens in between the end behavior, but we know it's going to point up on either side for even degree, positive leading coefficient. And then you go through the rest, like odd degree, positive leading coefficient. On the left side, it's pointing down or negative infinity. And on the right side, it's pointing up or positive infinity. So this is the end behavior chart. This is basically the 4 possible answers for end behavior, kind of written in a chart form that you may want to jot down for your notes. Okay, let's go back to the assignment. So for the announcement, again, Delta Math, your ACT number 6, Math Plaza, and then quiz at the end of the week. If you have any questions, please let Miss Lee know. I've included her email up here if you'd like to email her directly. And I think that's everything. Have a great week.